Hello, today we'll be doing Cambridge Lower Secondary Checkpoint syllabus in that Stage 9 Displacement Reactions. I'll be covering the entire chapter Displacement Reactions, and my next video will be about past paper questions of the same chapter. Question paper solving on checkpoint will be posted after I finish my checkpoint exam. So let's get started. Displacement reactions. Displacement reactions. A displacement reaction takes place when a more reactive substance displaces a less reactive substance. Displacement meaning replacement or replacing. So this means that, for example, I've given an example, copper and sodium. Sodium, as you can see, is reacting more vigorously in oxygen, whereas copper just produces this black powder over here. So, sodium therefore reacts more vigorously. It is a more reactive substance. This is a least reactive substance. So, in a reaction, if with sodium and copper, for example, anything, a reaction with sodium and copper, sodium will displace copper in a compound or a salt whatsoever, or salt solution whatsoever. The more reactive substance, that is sodium, will displace the less reactive substance, copper. The reactivity series. You must be familiar from grade 7 about the reactivity series. In grade 8, it's just a recap. So the reactivity series, for me it's just a recap because I've already finished it last year. So the reactivity series lists out elements in respect to the reactivity. The more reactive substances are at the top and the less reactive substances at the bottom of the table. So, as we saw with the same previous example, sodium is more reactive than copper. So, most reactive, less reactive. So, sodium is more reactive, so it's on the top. Copper is less reactive, so it's on the bottom. So therefore, the elements on the top of the table are more reactive. The elements at the bottom of the table are least reactive. So therefore, it lists elements based on the reactivity. This is the most, second, third, fourth, fifth, it goes on like that. Finally, the least reactive. Substances that don't react with oxygen, water, or acids are called inert. These substances are gold and silver, but silver reacts with only sulfur, which is present in air. But since it doesn't react with oxygen, water, and acids, gold and silver are termed inert. That means they do not react with these three. The reactivity series provides a clue on how metals will react with each other. There are two nonmetals used in displacement reactions. They are carbon and hydrogen. Carbon and hydrogen are the only two nonmetals which can displace other metals. It's not given in this table, but it's also present in between these. A good way to remember the reactivity series is with mnemonics. Example displacement reactions in water molecules. So we are going to see certain displacement reactions in water molecules. The displacement of hydrogen by magnesium. Hydrogen, which element is H. Okay, so hydrogen is displaced by magnesium. Hydrogen is a non-metal, so the two non-metals which can take place in displacement reactions are hydrogen and carbon, if I'm not wrong. And magnesium is a metal, so magnesium is displacing hydrogen in water molecules. So magnesium slowly displaces hydrogen present in water molecules to test the product magnesium hydroxide. So from last year, if you can remember the equation, metal plus water gives metal hydroxide plus hydrogen. So the metal hydroxide in here it's magnesium hydroxide. So to test magnesium hydroxide, an indicator called phenolphthalein can be used. Phenolphthalein can be used to test for magnesium hydroxide, the product of this displacement reaction. Now, when this is a magnesium ribbon and this is phenolphthalein, an indicator. So, magnesium ribbon, this is the magnesium ribbon. Now, the hydrogen which is present in the water, the magnesium is displacing this and the hydrogen is coming out as bubbles. Displacement of hydrogen by potassium. Like magnesium, potassium is also another metal which displaces hydrogen. The hydrogen present in water molecules is displaced when potassium is reacting with it. Potassium hydroxide is formed. So this is potassium reacting in water. So once potassium is placed in water, it bursts immediately into flames. That is a property of potassium. That's why it's the most reactive element in the reactivity series. It's the first, if you can remember. So hydrogen, which is not as reactive as potassium, because hydrogen is not as reactive as potassium, it is displaced by potassium because potassium is more reactive than hydrogen. So the word equation for this is potassium plus water gives potassium hydroxide plus hydrogen. It's the same word equation, just replace metal with whatever metal is there, potassium. This is from last year. I hope you have not forgot. Last year means grade 7, stage 8. So hydrogen is replaced, or better you can say it as displaced by potassium. Now displacement of metals. So far what we saw was displacement of non-metals by metals, where the non-metals displace no where the metals displace the non-metals. Now we are going to see metals displacing metals. So displacement of silver by copper. So now here you can see in the first flask there is a solvent of silver sulfate, and this is a copper wire. A copper wire is placed in silver sulfate solution. After a long time, you can see this is formed. This is nothing but silver which accumulates on copper. This is because in the reactivity series, copper is more reactive when compared to silver. So the silver deposits on top of the copper while the copper goes into the solvent. So the solvent turns into copper sulfate and silver accumulates on top. That can be represented by copper plus silver sulfate gives copper sulfate plus silver. Same thing is explained in this paragraph. When a copper wire is added to a solution of silver sulfate, the copper displaces the silver in the solution and the silver deposits on the wire. Now, displacement of copper by iron. This is another example. So, this is a solution of copper sulfate. Here this blue color solvent is called copper sulfate, and here is an iron nail. When this iron nail goes inside the solvent of copper sulfate, that time what happens, the iron in the nail goes into the solvent and and the copper in the solvent deposits on the iron. This is because iron is more reactive when compared to copper. That's why it displaces copper in the solvent, in the sulfate. So the copper, this plus copper deposits on the iron nail, just like how the plus silver deposited on the copper wire. The same thing is explained in this paragraph also. When an iron nail is placed in a solution of copper sulfate, the iron displaces the copper in the sulfate and the copper deposits on the nail. So this brown color over here is nothing but copper. The use of displacement reactions. Okay, now displacement reactions are used in many places in real life. It's applicable in many places in real life. Let's see where it is. Displacement reactions are used in many places. It can be used in joining two metal rails together. So here you can see two metal rails, railway tracks. The rails, two of them are being welded and joined together. Here displacement reactions are used. It is also used in tablets which are used to treat indigestion. So most probably a more reactive element is present in this tablets, and it can treat indigestion. So that's all. Thank you for watching this video. If it was helpful, please like, share and subscribe to our channel. We'll be posting many more videos on my sister will be posting on AS and A level, and I'll be posting on checkpoint. And after I finish my checkpoint exam, I'll be posting solved papers as well. Until then, only syllabus videos. Thank you for watching this video, and after this video I'll be posting another video on question solving. Thank you.